Hello everyone, this is the contestant number FSL142 of FREESCALE Kinetis L series MCU Design Contest 2014. My project title is EDMSCALE, Electronic Distance Measuring Scale. This device is used to find out the distance between the 2 points on the ground. The device is based upon the principle of the tilt sensing with the help of an accelerometer. An accelerometer MMA8451Q from the FREESCALE semiconductor is used to measure the tilt of the device with respect to the horizon. Ultrasonic sonar at the bottom of the device is used to measure the height of the device above the ground. And Kinetis L series MCU from the FREESCALE is used to process the information of the tilt and the height to calculate and display the distances on the LCD attached to it. Tilt angle alpha of the device with respect to the horizon is measured with the help of the accelerometer. Accelerometer can measure the acceleration along its three axes. Let the acceleration along the x-axis is ax and acceleration along the z-axis is az. The application of the gravitational force G can be utilized to measure the tilt angle alpha. On resolving the acceleration G along the two axes of the accelerometer, we get ax. Accelerometer's acceleration along the x-axis will be G sin alpha, and accelerometer will experience the acceleration of G cos theta cos alpha along the z-axis. Now dividing the ax by az, we get tangent alpha. Now according to the famous trigonometric identity of the triangle, D is equal to h upon m tangent alpha. Now using the equation number 1, we can calculate distance D is equal to h into az upon m ax. So the information of height and acceleration can be used to measure the distance D. Now I am going to measure some distances with the help of the device. Device is held at a suitable height above the ground and device is pointed towards a point up to which the distance is to be measured. Now I am pointing the device towards the 11 and device is also reading 11. Now I am pointing the device towards 15 and device is also reading 15. Now I am pointing the device toward 18 and device is also reading 18. When the user tilts the device to pointing it towards a point up to which the distance is to be measured, the ultrasonic distance sensor at the bottom of the device also experiences the same amount of the tilt. So it will measure the slant height of the device above the ground, and the calculation data of the distance based on the slant height would be wrong. So for this purpose, the ultrasonic distance sensor is mounted on a servo platform. This servo platform can perform the relative motion with respect to the chassis of the device. The servo platform is attached to a small brushed DC motor that is connected in the PID closed loop with the help of the second accelerometer at the top of the device. The accelerometer is MMA8451Q from the FREESCALE semiconductor. The purpose of mounting the ultrasonic distance sensor on the servo platform is to keep the ultrasonic distance sensor always parallel to the ground so that it will measure the perpendicular height of the device above the ground. Now I am going to measure some large distances with the help of the device. The distance up to that block is 5 feet as read by the device. Now I am going to measure the distance up to the brick. The distance is 13 feet as measured by the device. Now I am going to measure the distance up to the wall. The distance is 25 feet as measured by the device. Now I am going to conclude my project. The conventional handheld electronic distance measuring devices using the principle of the ultrasonic sonar. They transmit a echo pulse, and that echo pulse is reflected back from the object up to which the distance is to be measured, and based upon the time information that the ultrasonic wave takes to travel to the object and return back to the receiver, the user calculates the distance. But in the real life situations, that reflecting surface is not always possible. For example, to measure the distance between the 2 points on the ground, the reflecting surface is not there. So this device uses the principle of the tilt sensing using the accelerometer, and based upon the tilt sensing information, the device calculates the distance. So this device has the advantage over the conventional handheld electronic distance measuring devices that uses the ultrasonic distance sensors. Comparing our device with a costlier solution like the prism based theodolite, this device uses the accelerometer, they are very cheap. So this device is the cost effective solution for the various consumers in the market. For example, photographers can use this device for finding the hyperfocal length of their cameras, and civil engineers can use this device for carrying out the surveys, and there are various other potential consumers of the device, and the device is expected to fulfill the market demand of these potential consumers. Okay.